last video, that is chapter 3 on kinematics, I have finished all the related topics on kinematics and the associated topics before that videos. And now in chapter 4, means this video, I will show you some numeric problems or some examples I will show you, so that you could get a good grasp on the subject or the theories that I have taught. The first of that is chapter 4, kinematics. So this first problem, it is on a reference frame, which is an associated topic of kinematics. So there is a condition, is a plane which is flying on the air, okay, with the velocity towards east. This is north, east, west, south. So towards east with a 250 meter per second, and on the ground there is a car which is moving with the velocity in the same direction, in the east direction, with a 50 meter per second, and a person standing on the ground looking at the different motion nearby, and by virtue of that he also looking at the car, this car, and the aeroplane. So the condition, so we will assume there will be three different conditions where the observer will be lying on different reference frame. The first one would be the ground and the person who is standing on the ground. He will be our first observer. So if I assume he will be the first observer, as his velocity is 0 meter per second, that means in rest. So what he will observe? He definitely will observe himself at rest, because he is on the earth, and relative to earth his relative velocity to earth is 0. Relative velocity to earth is 0. So he himself will see his speed as 0. This is first prediction or assumption, you can say. Because why I am saying assumptions? Because all motions are relative. There is no absolute motion. Okay. So if we choose the reference frame accordingly, we'll see the things accordingly. We'll see the motion of the objects or any particles or anything which is having motion or at rest. I will see accordingly with respect to the state of the observer. So the first observer who is in rest, he will see himself as rest. When you see it, he will see the car is moving at 50 meter per second east. Third, you will see the aeroplane is moving 250 meter per second east. If he compares if he compares aeroplane to car, then he will see that aeroplane is moving 200 meter per second faster than car. Fifth, if we compare car and aeroplane, there may be possibilities that he will see that car is 200 meter per second slower than aeroplane. So this much assumptions or prediction he can observe and can give it to someone who will be interested to bring some relation or some, he want to do some calculation for himself, he can do any calculation. So these are the information respective to his own state of motion. He can presume or assume these conditions. Now if we change the reference frame from the person who is standing on the ground to somewhere. Now I am changing the reference frame. I am changing. This is again the person standing there on the ground at rest. Now the observer I am shifting to the car. Now what he will see, the car person, he is at rest. Why? Because the relative velocity with the car to himself is 0. Why? The relative velocity is 0 with respect to the car, where he is sitting. So if I have chosen this as a reference frame, so this time this is my reference frame, and the observer is in the reference frame itself, so he will not experience any difference in velocity to the reference frame. So he will see himself at 0. So according to him, if he sees this person, he will see the person is moving with the 50 meter per second west, because he is moving on the car is moving on the right hand side with the 50 meter per second eastwise. Now he himself is assuming he has rest, so he definitely will see this person to move on the other side with the same velocity, 50 meter per second. Third assumption, if he sees the aeroplane, he will see the aeroplane is moving 200 meter per second east, because the aeroplane is faster than him, so he will not able to see it going other side, rather he can see the plane is moving the same direction. Okay. Anything else he will see? He has assumed about plane, he has seen the person, he has seen himself. So these are the condition of when we have chosen the observer is on the car. Now the third case, where the observer, if he is in plane. So first thing, the foremost thing, if reference frame and the observer is the same, so he will see himself at rest. Second, if he observe the car, as he is in 250 meter per second speed and car is slower, so the car will never able to pass it through, rather car will constantly be differ from the plane when they are moving even in the same direction. So he will see the car is moving with the 200 meter per second, the difference of their speed towards west on the opposite end. Okay, and he will see the person on the ground moving with, taking his speed, this frame speed, on west side, on the backward side. So this will be his assumption, and you can say is report to someone if he see what he is seeing. Okay, and at the same time, all the moving vehicles, moving aeroplane or vehicle, whatever they will see similarly all standing, all static things. There may be tree, there may be something hill and all that. All are moving towards the opposite side of their motion. Okay, which is nearer. So this is the example by which I could probably have explained the theory that I have taught, what is exactly meant by the reference frame and what is the choice of reference frame by which I can study any motion. Okay. So the next comes on the vector, in which there are some vectors written at following to this question. So the question is which are the vectors which are among vectors. So your choices are 50 Newton, 50 meter, 0 meter east, 30 meter per second bar, 20 meter per second, 10 meter per second west, 70 north. Okay, so let me start with the first one. 50 Newton. Newton is the unit of a force. So there are numeric, there are unit, but what is missing to define as a vector? Direction is missing. So I cannot take it as a vector. If as per the vector definition, it must have numerical, must have unit, must have direction. These three combination, if it is there, then only we can say this is a vector. So this is not complies this condition, so it is not. Again, unit, meter, no, this is not. So this could be a scalar distance. 0 meter east, 0, we can assume the value of the vector is 0. In case of null, it is such, because here the starting point and end point meets each other. So that definitely is a vector, because these are measurement, this has unit, these have direction. So this is a vector. 30 meter per second, numeric is there, unit is there, and this sign depicts is a vector. So this is well taken as a vector. 20 meter per second, again numeric is there, unit is there, direction missing, no. 10 meter per second west, numeric, unit, direction, okay. 70 north, numeric is there, direction there, unit missing, so it's not a vector. So if you follow the same rule, you can able to tell what is a vector, what is a scalar. Okay. Going to the next problem. Problem number 2 here. How unit vector is represented? How unit vector is represented? So there are some choices. We have to choose among the choices given. A cap, A bar by, it is in bold, A mod, A bar by A only, A bar by this one. So unit vector, this is definitely an answer, because this is a special signature for unit vector. Any unit vector, as we know, towards x direction I, small I cap, towards y direction j, small j cap, and towards z direction k cap, small k cap, are the three unit vectors. So this has got a definite notation with a cap. So if any letter followed by a cap on his head, so it will denote any unit vector. A bar, it is a vector, and vector by its mod value, that means the numeric value, because vector is nu and direction, when you divide it with n, so it cancelled out the unit, cancelled out the numeric, and you will get the unit direction. So this is a unit vector. So that definitely it is yes. A bar again a vector. This a two kind of notation where only simple a also sometime will denote the magnitude. So this is also okay. A bar is vector. This a bar mod is also the similar of these two kinds. So this is the perfect designation for representing any vector if it is known. Then if I take the mod value of that, I will get definitely unit vector. So this is definitely an perfect representation of unit vector, or directly if something has to be written, that is the unit. So, but all are correct here. Moving to the next problem, problem 3. A particle moves from a particle moves from A, this is point A, to point B, then the displacement is how it is represented. There are choices: B A bar, A B bar, minus B A bar. So if these are 2 points A and B, let's say A and B, and the movement is starting from A, so definitely when starting from A and ending at B, so direction of the arrow must be this side. So this kind of vector, when it is represented, always you have to start from the starting point, ending with the end point, and followed by a arrow on his head. So this is the representation. So this way, this is not correct, this is correct. But if I assume there are one vector which is parallel to this, having same magnitude, and starting from B and ending at A, so arrow will be there. So what would be the representation for this vector? This vector has to be, because if I assume this is the positive direction, so as per the arrow, this will be a negative direction, and as it is starting from B and ending at A, this will be the vector. Now if the magnitude of these two vectors are same, that means I am saying AP and equal to BA. So then if magnitude are same, as vector only differs by the direction, and that too just opposite, 180 degree apart. So in that case, these are related with a negative sign by the other vector. So these vectors cumulatively called the negative. So this vector is called the negative vector to this, because this is positive direction as per the as per our we can say that acceptance, universally acceptance, each side is the positive, as because this is representing the positive x direction, so this is positive, and this side it is west, representing the negative x direction, so that is negative. So this will be the negative to this, but magnitudely they are same. So this is also a correct answer for this question. Okay. Okay. Moving next. Whether following is vector. There are some example whether following are vectors. So there are choices given: force, power, non-uniform velocity, rotational velocity or speed velocity. Okay. So let me come one by one. Force. What is force? Force is nothing but your m into a, the mass into acceleration. So mass into acceleration for this force, it is a linear. So mass, if it is a mass is being pushed by a force F, it will move towards the same in which the force is being applied. Okay, so if it is so, then mass and this A is with the dot product of vector. Okay, so in case there is a dot product between two vectors, mass is a although mass does not depend on the direction, so mass is a scalar itself. Acceleration is a vector. So any scalar into vector will give you a vector itself. So that means if f is a vector. As I told earlier during theory class, any scalar, if it is multiplied with a vector, will give a vector. So mass is a scalar here because mass does not need any direction. A mass is its inherent property of any object. So mass anywhere in the universe, anywhere in the world, anywhere you place, the mass won't change. The value of mass is a scalar. Okay. And acceleration is a vector. So the force, which is a multiplication of mass into acceleration, is definitely a vector. So this is a vector. Power. Now power, how will I get? Power is nothing but it is defined at the rate of doing work. So power is nothing but work done upon time, the rate of doing work. Work done, we know, work done is nothing but what? Work done is the force into displacement by time. Time is anyhow it is a scalar. Force into displacement. Force, when we apply force on any object, there could be a displacement. Let's say it has displaced this side. So the force and the displacement, it is in a linear path. They are collinear. So these two vectors comes as a product which is a dot product. So f dot d, two vectors, when two vectors comes with a dot product, the result will be a scalar only. Why? Because f dot d can be written as f mod d mod with a cos theta. Now what is the theta between f and d? Because they are collinear, so theta is 0. What is cos theta here? Cos theta is equal to 1. So this is simply f into d. So this will give you and this in case it is dot product, the resultant will be a scalar. Okay, so this is the thumb rule, because cross product of anything, because if there is a cross product between two vectors, that will produce a vector, because cross products resultant, it comes with a sine theta. How it is happening? In later when we will study the rotational motion with respect to the linear motion, there we can understand the difference of that, why we call the cross product is a vector, how it is defining, and why the dot product is a scalar. Okay, only thing you can understand for dot product, the direction of the resultant, because what is resultant here, the product of these two vector is a resultant. The resultant does not change the direction. Okay, so as it is following the same direction, so it won't be a unique one that is following the direction of f and d, and it is collinear. So there nothing is changing. Okay, the resultant. If in case cross product if I take, then the resultant changing its direction. That we will study during discussion of rotational motion. So as of now, just remember, for dot product, the resultant will be a scalar. For a cross product, and it is a vector. So where it will come as a dot product, what the result will come cross product, that will be more clear when we will discuss on rotational motion. But for linear motion, you just keep it in mind. The two vector, if it is being multiplied, if it is necessary to multiply, that resultant will give you a scalar only for linear motion. Okay, so in this case also, f into 2 will produce a scalar, so that is the work done. So work done is a scalar by scalar, so it will be a scalar only. Okay, non-uniform motion. So non-uniform velocity, how will it produce? The non-uniform velocity can be produced by, if the velocity is non-uniform, that means the in a motion where the there is a different velocity is there in same span of time. Let's say I am just assuming there is a time lag of t every time, and during that time, if it is constantly changing the velocity, that means the change of velocity, the non-uniform velocity, the change on the velocity, let's say it is u and this is 2u, then after it is 4u, so that means in between the changes is to u, in between the changes 2u. So if time lag, this will come here after the time lag. So if it is the time lag, the velocity is incremental, so that is a non-uniform. Or otherwise there could be one possibility is, if the velocity if something moving in a rotation circular path, so the velocity every instant it is changing, because the velocity is the tangent to the certain point through which the motion is happening. Means if it is following the circular path, so on that, in every point, if I draw a tangent, that will give you the velocity at that instant. Okay, so instantaneously the velocities are changing, so that also be a example of non-uniform velocity. But in both cases, if you see this, there is a direction always, because it is following the same linear direction, even though the velocity is incrementally changing, or maybe not sequence, not in the same manner it is changing. There may be a possibility the velocity is haphazardly changing. So whatever change is happening, but change is happening in the same direction. So we cannot say that it doesn't have means direction. It has a value, it has a direction, that is a linear. In this case also, instantaneously every point, even if it is changing constantly, the velocity is changing constantly, but instantaneously that velocity vector has some direction. Okay, so in this case also, non-uniform velocity is a vector. Now come to the rotational velocity. Rotational velocity is somewhat similar to the non-uniform when it is moving on a circular path, because the same theory or same concept I can put it there, because the velocity is that any point of time, it is the tangent to that point. If I want to calculate the velocity at this point, if I draw a tangent to this will denote the velocity at that point of time, and respectively the velocities will change, because this direction is changing, although if it is of same value, but if due to the change in velocity, the amount will change. So although it is changing constantly, but at certain point of time the velocity having some direction. So rotational motion also a vector. So why this is being discussed? Because during explaining the problem, you should not be confused whether it should be taken into consideration the equation of motion, because the equation of motions all are considered for vectors only. Okay. So coming to the next. Now there is a person who has started from point A, moving a distance 4 on east. Then after, from that point he has moved 3 meter, 4 meter initially east, then 3 meter change the direction towards south, then 4 meter again towards east, then 4 meter again towards south. So you have to calculate the distance covered and displacement. So as you know, the distance traversed is the physical length of the path, actual path of the actual length of the path that he followed. So he has followed this path. So what is the length of that? If I add all the distances he covered individually, then I will get the total path, that will come as 14. But what is the displacement? Displacement says the shortest distance between initial and final position. So this is the definition of displacement. So if I take the initial point is A and final point is B, then if I add this point together, I can reach a point which is to be considered, and this distance between the straight distance will be the your displacement. Now this can be solved by individually calculating, because anyhow this diagram will definitely meet the shortest distance. If this will meet there, so this will be a 90 degree. 4 and 3 individually can calculate, this is 5 and 5. Or else now it is a very symmetrical one. Now this theory can also be used, because vectors can be parallelly shifted. So these are parallel vectors. So if I shift it with the consecutively with this 4, so that will not change the vector. So this is your A. Now this vertical one, this also parallel, so we can put one after one, 3 and 3. Then this will be the last position B. So if I join this one, so this will be a single right angle triangle. And if we add this, because these are the linear quantity, because they are not changing direction, so that definitely can be added as we add the scalar quantity. So this will give you 8, this is equal to 6. So the diagonal will be 8 square plus 6 square whole root is equal to 10. So the result will match. So this also you can use it. Okay. Moving to the next problem. 6 says that a motion is there which is circular in it is in circular path. The motion is happening in the circular path. Okay, this is the origin of that, the center. So the position vector, that is the radius of it, from starting at A and moving at a distance, at an angular distance B, angular distance theta to a point B on the circumference. So in that case also you have to find the distance covered and displacement. So how do you do that? So the distance will be the path, the circular path by which it is moving. So this is, if I say the arc length S, so from the circle we know this is nothing but S is equal to r theta. S is the curved length, is equal to r theta, where r is the radius of it. So this you know, theta should be in radian. Should be in radian. Okay, so even if it is given in degree, you have to convert in radian. How will you do that? Because 1 radian is equal to pi by 180. Because 180 degree is equal to pi radian, so 1 radian is equal to pi radian by 180. By that conversion, you can change this value. What about the displacement? So displacement is the shortest linear distance. So if I join these 2 points directly with a straight line, so this will be your displacement AB. As I have started for B, so that will be denoted by AB bar. What will be that? So if I join a vertical from this on this will divide it into 2 right angle triangle. So in this case, so this angle is nothing but theta by 2. So now if I consider this right angle triangle, so this will be, if I assume the total length is 2L, total length means AB is 2L, so I can assume if it is the point P, so AP is equal to L. So this is this I know is the radius. So if I take sine of theta by 2, this is equal to this AP by the radius R, hypotenuse. Okay, now what is AP? AP I have taken L, so L by R is equal to sine theta by 2. Okay, so then L is equal to R sine theta by 2. Okay, so that means L. So what is your total length AB? AB is 2L. So AB will be 2 into 2R sine theta by 2. So this will be your, you can say it is a standard formula you can use in case theta is given, R is given. So this formula will give you the displacement. Now if theta by 2 is small, so that sine theta by 2, again this equation you can use, which is again 1 minus cos 2 theta by 2. So this will give you some relaxation for calculation. If let's say theta is, here it is 15 degree, theta by theta is 15, then this case, this will be theta. Now if I say theta by 2 is equal to 15, so it will be very difficult to calculate sin theta by 2 means sin 15. Rather, if I use this formula 1 minus cos theta by 2 under root, so theta, instead of taking theta by 2, you can directly put theta is equal to 30, and the cos 30 value is known to you. So this, some cases that will be very advantageous if you remember this formula. Okay. So this is up to this, and next video I will move on to the problem number 7 onwards. Thank you.